2.4 Deductive Reasoning. In this lesson, we are going to use the law of detachment and the law of syllogism to do some deductive reasoning. Deductive reasoning is sometimes called logical reasoning. Okay, if you remember inductive reasoning, we used patterns to make a conclusion. And we found that that could be a little bit problematic if you didn't have enough data points or if the data changed over time. Deductive reasoning uses logical reasoning from given statements or facts to draw our conclusion. So our first one here is the law of detachment. And this says if the hypothesis of a true conditional is true, then the conclusion is true. So we have a true conditional. And if we have something that matches the hypothesis, then we can say that you can make the same conclusion. So down here it says if you use the law of detachment, identify the hypothesis of the given conditional. So we have our given if-then statement. And if the second given statement matches the hypothesis, okay, so we want our second statement to match our hypothesis. So we want to match the hypothesis, match our if, our requirement. If the requirement is met, then you can make a valid conclusion. So let's look at how this works. All right, so we are given, told we are given true statements. We are given if a student gets an A on the final exam. That's our requirement. That's our hypothesis. That's our requirement. Then the student will pass the course. So our second statement tells us that Felicia got an A on her history final exam. Does that match our given hypothesis? Does that match our requirement? Yes, she got an A on a final exam. So because it matches the hypothesis of our true conditional, then by the law of detachment, we can conclude that Felicia will pass her history course, because that was our conclusion from our given from our true conditional. Then you will pass the course. Let's look at the next one. If a ray divides an angle into two congruent angles, that's our requirement. The ray divides an angle into two congruent angles, then the ray is the angle bisector. So let's look at what we're given here. Ray RS divides angle ARB, so that angle ARS, we need to fix this. This should say congruent. So that angle ARS is congruent to angle SRB. Does this meet our requirement? We have a ray that divides an angle into two congruent angles. So yes, we matched our hypothesis. So now we can make a conclusion. What conclusion can we make? We can make the conclusion that the ray is the angle bisector. So we can say ray RS is an angle bisector. We are given a true conditional, and if we can match the requirement, we can make the same conclusion. Let's look at the next one. If two angles are adjacent, so our requirement is two adjacent angles, then they share a common vertex. So let's look at our next statement. We don't need the if. Angle 1 and angle 2 share a common vertex. Is that our requirement? No. This is our result. This does not match the hypothesis. So we cannot make a conclusion. We must meet our requirement. Our requirement is not met. All right. Pause the video. You try the next two. The first one says, if there is lightning, that's our requirement, that there is lightning, the result is that it's not safe to be out in the open. So our statement says Marla sees lightning from the soccer field. Does that meet our requirement? Our requirement is there is lightning, and that is met. The soccer field doesn't matter, Marla doesn't matter. All that matters is we meet our requirement. There is lightning. So we can make a conclusion. We have matched our hypothesis. We have met our requirement. We can make a conclusion. And what is our conclusion? It's not safe to be out in the open. So it is not safe for Marla to be out in the open. Number B. If a figure is a square, then its sides have equal length. The requirement is the figure is a square. So our second statement says figure ABCD has sides of equal length. Do we meet our requirement? No, our requirement that it's is square. That is not met. We don't match our hypothesis. We don't meet our requirement. There is no conclusion. And if you want a counterexample for that one, a rhombus has sides of equal length, and it is not a square. So you must match the requirement. You must match the hypothesis. If you match the if portion of the statement, then you can make the conclusion. You can make the same conclusion. The conclusion will be true. If both hypotheses are true, they will have the same conclusion. All right, next is the law of syllogism. The law of syllogism is going to let us state a conclusion from two true conditional statements. Now, the thing that has to happen here is the conclusion of one is the hypothesis of the other. So what we're going to have is if, let's underline law of syllogism here first, law of syllogism. Here in our symbols says if P implies Q, and that is a true conditional, and Q implies R is a true conditional. So we have two separate conditionals, but look right here. The conclusion of one matches the hypothesis of the other. Then we can simply cut out the middleman there and say, well, P implies R. So let's look at this. If it is July, then you're on summer vacation. If you are on summer vacation, then you work at the smoothie shop. So our first requirement is that it's July. The result is you're on summer vacation. That result becomes our next requirement. Well, if you're on summer vacation, the result of that conditional is you work at the smoothie shop. So we have conditional 1 and conditional 2. Then we can simply combine the hypothesis of the first one, if it is July, and the conclusion of the second one, then you work at the smoothie shop. I'm sure that in math prior to this you have seen the transitive property. If A equals B and B equals C, then A equals C. That's very much what this is like. All right, let's do some examples. We are given, if a figure is a square, then the figure is a rectangle, and that is true. Now let's look at the next one. If a figure is a rectangle, does that match one of our parts? Yes. If a figure is a rectangle, matches the green portion, then the figure has four sides. So does the conclusion of one match the hypothesis of the other? Yes, it does. So we've got those two parts right there that are the same. It has to be the conclusion of one of the statements and the hypothesis of the other statement. So we could use the law of syllogism to say if a figure is a square, then the figure has four sides. All right, let's look at the next one. If you do gymnastics, that wasn't the color I wanted. If you do gymnastics, then you are flexible. Let's look at the next one. If you do ballet, does that match anything that we have? No, it doesn't. So new color. And the conclusion, then you are flexible. Do we have two parts that match? Yes, we do. But this time, the conclusions match. And same conclusion is not what we're after. You cannot use the law of syllogism. You cannot make a conclusion. So you have two true conditionals. The hypothesis of one matches the conclusion of the other one, and then you can combine them. All right, pause the video and give it a shot. All right, the first one says, if a whole number ends in 0, it's our requirement, then it is divisible by 10. That's our result. The next one says, if a whole number is divisible by 10, requirement, then it is divisible by 5. So does the conclusion of one match the hypothesis of the other? Yes, it does. So we can combine them together and say if a whole number ends in 0, then it is divisible by 5. Look at the next one. If ray AB and ray AD are opposite rays, then the two rays form a straight angle. So our requirement is that our two rays are opposite rays, and our result is they form a straight angle. The second one says if two rays are opposite rays, then the two rays form a straight angle. Is the requirement of one the result of the other? No. These are just the same statement over again. We cannot conclude anything. Basically, they say the same thing. So there's no conclusion here. All right. Last part. You can use the law of syllogism and the law of detachment together. So let's look at what we have here. It says, if you live in Accra, then you live in Ghana. The second statement says, if you live in Ghana, oh, that matches. We live in Ghana. Then you live in Western Africa. And finally, Isa lives in Accra. That matches up there. We have a couple of options here. We can use the first two statements in the law of syllogism, right? To connect to get rid of those two. The conclusion of one is the hypothesis of the other. And we can say, if you live in Accra, then you live in Western Africa. And then we can use this new statement because our third statement here matches the hypothesis. It meets the requirement of our new conditional. So we can use our new conditional here, and we can say that use the law of detachment to say that Isa lives in Western Africa. We also could have taken these two statements to say that use the law of detachment. Oh, not going to answer that question. Never mind. All right, so you see how we did that? Go ahead and pause the video and you try the next two. All right, we are given if a river is more than 4,000 miles long, then it is longer than the Amazon. So requirement, more than 4,000 miles, result, longer than Amazon. Our second conditional says if a river is longer than the Amazon, then it is the longest river in the world. You should see right here that we have a conclusion and a hypothesis that match. So you should be thinking law of syllogism. And then our third statement says if the Nile is 4,132 miles long. Now you should say to yourself, hey, up here we had a requirement that said more than 4,000 miles. We've got a more than 4,000 mile river here. So that should look like the law of detachment. So what we did first was we took statement 1 and 2 and we used the law of syllogism, and we said if a river is more than 4,000 miles long, then it is the longest river in the world. And then we matched up our new statement with our third statement here, which the requirement is a river that is more than 4,000 miles long, and we are told that the Nile is 4,132 miles long. We used our law of detachment saying our hypotheses match, then our conclusion is true. So that says then we have the longest river in the world, so the Nile is the longest river in the world. Now the next question, you see why I didn't say anything that I was going to up above, says does it matter whether you use syllogism or detachment first? And it's no. Because let's look at this again. What if we started out by putting 1 and 3 together? 1 and 3, the requirement of statement 1 is a river is more than 4,000 miles long. Statement 3 says the Nile is more than 4,000 miles long. So we could make a statement that the Nile is longer than the Amazon. So now we have a new statement here, and let's look at statement 2. Statement 2 says if a river is longer than the Amazon. Well, we meet that requirement with our new statement, so then we can use the law of detachment again and say the result is true. Then it's the longest river in the world, so we can say the Nile is the longest river in the world. We get to the same result either way. So it doesn't matter what we do first, it just matters that we use the rules. So if you're going to use the law of detachment, you have a conditional statement, and your new statement must meet the requirement, must match the hypothesis. If it does, you can state that the conclusion is true. You can make the same conclusion. If you are going to use the law of syllogism, you must have 2 true conditional statements. And the hypothesis of one is the same as the conclusion of the other. One of them, the result, is the requirement of the other one. So it doesn't work if you have the 2 same hypotheses and different conclusions. that does not work. You cannot make a new conclusion out of that. So just be careful. Make sure you are uh, mark what you're talking about. Colors, geometry is easier in color. It will help you focus on what you're looking at. And I really believe that this lesson is going to be kind of fun.